Hello, today I am presenting to you HyperDapp, a toolkit for designing user interactions with smart contracts. The problem HyperDapp is solving is that currently building dApps is still a very costly and time-consuming process. For a developer to build a dApp, not only will they need to construct the smart contract and deploy it, but they will also need to build out the interface layer for users to interact with those smart contracts in the form of a website or a single page application. This requires more time to build, design, and test out before users can interact with these smart contracts in any acceptable user experience. dApps are not very interoperable right now. A developer can build out a website to interact with these smart contracts, but currently user experiences with the internet has become much more rich in other forms of communications and platforms beyond web apps. With social platforms, chat applications, video games, AR, VR, mobile applications, and the metaverse, these are platforms that have not yet reached maturity in dApp adoption yet. And for a developer in the future, this can be additional overhead needed to build on top of these platforms if a standard protocol for this kind of interoperability is not available. And the last problem that has been identified is that beyond smart contracts on the blockchain, additional layers of business logic is typically built into front ends on how the interface is to properly communicate and process functions on behalf of the user. This business logic is typically non-transparent, can be single points of vulnerability depending on how the front end is deployed, and can be susceptible to exploits because this is a layer that is not verifiable or typically audited like a smart contract. An example of this kind of vulnerability would be the Badger DAO exploit that has resulted in $120 million in value lost on an exploit that was not on the smart contract, but on the interface layer of the dApp. The solution is HyperDapp, a new UI protocol for smart contracts. HyperDapp offers a suite of tools for developers to create user interface logic that can be packaged and sourced from decentralized registries on-chain, so that a user can interact with their dApp on any interface that supports the HyperDapp protocol. What will be demoed here is a flow editor tool for developers to design their interface logic and publish it to a decentralized registry, and a chat app currently supporting the protocol interpreter engine to showcase how a user interacts with these defined users flows and smart contracts with their MetaMask wallet. Let us begin with the flow editor. For this demonstration, we will be using a popular existing smart contract deployed on mainnet, World of Women. We will create a new workflow project and name it. The first thing we will do is load up the smart contract API, which can be sourced from Etherscan if it has been verified, or it can be loaded up as a JSON file. After, we will create a flow in the flow editor. We select the API we want to use and create a workflow function. In this case, we want to do a Boolean function and name it isOwner to check if the user is the owner of token ID 55. We will select the owner of method in the API, and the input we want is token ID 55. We then retrieve the current user wallet address from the context and do a comparison. Is the current user address matching the address returned from the owner of smart contract function? If the function returns true, we prompt the user to mint a new NFT. If false, we will return a message of our choosing. And that's it. We can now publish the workflow by clicking the button in the top right-hand corner. Let's now take a look at what an end user experience can look like when interacting with a published workflow. In this view, we are demonstrating how workflows could work on an end user interface like a generative chat application. On the left, we have the flow logic that has been compiled to our Cortex code and deployed by our flow editor tool to the registry. And on the right is an example of an end user interface that generates the behaviors based on the Cortex code. As we can see, the amount of code needed to run this dApp is significantly less than what would be used to create a React app with Ethers.js, and is far more lightweight so that it can be used on lower powered devices. Developers can have the option to use Flow Editor GUI tool or define the flows in Cortex code. All interactions are facilitated with an EVM wallet, and the interface on the right generates the appropriate responses depending on the actions the user takes and the defined behaviors of the flow logic. The code can be edited in the dApp, but any flows deployed to the registry is immutable, verifiable, and versioned. In this tool, a developer can deploy again if needed and can send a URL to their users to play with the dApp. The benefits that can be realized with the HyperDapp protocol are applicable to developers and end users. HyperDapp can be a very powerful tool for developers to build their dApps. Not needing to invest heavily in design and front-end development up front, a dApp can be deployed and sourced by many platforms, reducing the need for repeated work and reduce time to market by up to 90%. Workflows are essentially more secure because they are immutable and trustless. Deployed logic flows are sourced from decentralized registries and are verifiable. This is because they are sourced and compatible with all EVM supported blockchains, like Ethereum, all corresponding testnets, Polygon, Arbitrum, Phantom, Optimism, and many more. For an end user, they will have the ability to interact with their favorite dApps on any platforms with a conversational interface or an embedded iframe that supports an EVM crypto wallet and the HyperDapp protocol. Thank you for staying to the end of this video, and follow us on Twitter for updates on the HyperDapp protocol.